Good morning, dear students. Welcome for the physics class. So today we are going to discuss about the impulsive force and impulse of a force, or impulse of a force, also called as impulse. Actually, this topic has been deleted from your syllabus for this year only, but for competitive purpose, it will be helpful for you. So that's why I am going to explain this term. So here impulsive force is a different and impulse of a force is a different. Impulse of a force also called as impulse. Okay. So impulsive force means it is a force acting on a body for a very short interval of time. It is a force acting on a body for a very short interval of time. So, for example, we can consider hitting a cricket ball with a bat. So, when we hit cricket ball with a bat, the force exerted by the bat on the ball will be for a very short interval of time. Immediately when a ball comes into contact of the bat is going to exert a force for a very short interval of time. Okay, immediately ball will rebound, right? So that is an example for impulsive force. And one more example is kicking a football. Okay, kicking a football. While we kick the football, there the time up to which the contact is there between the leg and the ball is a very small, right? So there also the force will be acts on a body for a very short interval of time. So that is also example of impulsive force. And next comes impulse of a force, or simply we can call it as impulse. Don't get confused. In examination, if you have asked for impulsive force, you have to write this definition only. Impulsive force is different and impulse is different. Okay. So it is the product of average force acting on the body. So here it is the product of average force acting on a body and the time up to which it acts on the body. Time for which it acts on the body. Is it clear? So that is nothing but impulse. Impulse means product of average force into time. Right? Okay. Next, impulse is a vector quantity. Impulse is a vector quantity, and the SI unit of impulse is kV meter per second. Because here the SI unit of force is kV meter per second square into time per second. So there second, 1 second and second get cancelled. So that's why the SI unit will be kV meter per second. And the dimensional formula already we come to know how to write the dimensional formula. Here kg is the SI unit of mass and dimension of mass is m. Power is 1 here, so m is 1. And meter is the SI unit of length and the dimension of length is l. Power is 1, so power is 1. And the second, it is the SI unit of time. Okay, so the dimension of time is t. Power is -1. E raised to minus 1. So m raised to 1, l raised to 1, e raised to minus 1. Okay. And here we need to prove that impulse is equal to change in the momentum. Impulse is equal to change in the momentum. Momentum means it is the product of mass and velocity. Okay. And change in the momentum means it is the difference between the final momentum and the initial momentum. Okay. So now impulse is equal to, we know that force into time, that is average force into time. So force means mass into acceleration and into this time. So I'll write as mass, and acceleration I'll write it as final velocity v minus initial velocity divided by the time interval. Okay, into t. As you can see here, this t and t will get cancelled. What we have, m into v minus 2. If you bring that m inside, it is to be multiplied with v V and U both. So that's why impulse is equal to mv minus mu. So here u means the initial velocity and v means the final velocity. M into final velocity means the final momentum minus m into u means the initial momentum. So final momentum minus initial momentum is nothing but change in the momentum. I hope you understand. Okay. Next one. So we all know impulse is equal to force into time. Then what about force? Force is equal to, you just bring this time to the other side. So force is equal to impulse divided by time. How this impulse will act? How this impulse will act? For that we consider some examples. Okay. So I think you have all observed that in a cricket game, while catching the ball, player used to down his hand. Player used to move his hand down while catching the ball. Why? Why? Player, while catching the ball, he used to move his hands downward direction. Because in order to increase the time of impact, suddenly if he catch the ball, without lowering his hand, if he suddenly caught the ball, then what happens? Time of impact is very less, right? Time of impact is very less. If he lowers his hand, then time of impact increases. Look here, if the time increases, denominator increases, then what happens to the force? Force will be decreases. Okay? If time of impact increases, force will be decreases. That means he won't get any injuries. He won't get much force on his hand. Okay? By lowering his hand while catching, he increases the time of impact so that force acting on his hand is decreases. So he may not get injury. Suddenly, without lowering the hand, if he catch the ball, then what happens? Time is less. Denominator less means the total ratio is force increases, and he may get injured. Okay? And one more example we can consider. In a vehicle, shock absorbers will be provided. The springs will be provided. Why? Whenever the vehicles are moving across the bumps or humps, they will face the jerks, right? So, if we won't have the spring or the shock absorber, during that jerk, the time of impact is very less. Because of less time of impact, force acting on the vehicle and on the passenger who is sitting inside the vehicle will be more. Then the automobile parts of the vehicle get damaged, and also the passengers who are traveling in the vehicle also get injured. Okay? In order to avoid that, the automobile companies or the vehicle companies have invented that by placing the springs or a shock absorber, we can increase the time of impact between the jerks. If the time of impact increases, then what happens? Force decreases. So the person who is sitting inside the vehicle won't get much injuries, and also the automobile part of the vehicle will be safe. Okay? So let me consider one more example. So you have to consider a person who is falling on the hard ground. One case, a person who is falling on the hard ground, and in another case, a person who is falling on sand or loose soil. Who will get the more injuries? The person who will fall on the hard land or the hard ground used to get more injuries, and the person who is falling on the loose soil or the sand will get less injury, because when the person falls on the loose soil or the sand, the time of impact increases. body will not rebound that, okay, because the time of impact is large there. So the effect of force is less. So he may not get injured, or he may get smaller injuries as compared to the person who is falling on the hard ground. Whenever the person fall on the hard ground, then usually the body will rebounds, right? So because there the time of impact is very less. If the time of impact becomes very less, then the effect of force is more. Effect of force is more, so he may get the more injuries. Okay, so this is about the impulsive force and the impulse of the force, right? Just take a screenshot and copy it. And remember, whatever the examples I have given for the